order to perform thermostructural analysis on a heatsink, I have opened this Ansys Workbench and I am going to drag and drop the steady state thermal analysis onto the project schematic. And I am going to open the engineering data, go to the engineering sources, and I go to this general materials library, and in the general materials library I am going to select the aluminum alloy. And once I select this material, I am going to close this particular engineering data. Right now what I am going to do is I am going to right click on the geometry, say import geometry, and I am going to select this particular heat sink. And once I select this particular heat sink, then I need to double click on the model cell in order to open mechanical. So once I open Ansys mechanical, then we are going to do the further analysis. See, once the Ansys mechanical has opened, now what I am going to do is I am going to go to the geometry branch and I am going to change this material from structural steel to aluminum alloy. And once I did this, I am going to right click, say generate mesh. Once I have measured the body, I am going to right click on the steady state thermal, going to insert, go to this heat flux option, and I am going to select this bottom face on which I am going to apply the heat flux. So the value of the heat flux that was given to us is 1000 watts per meter square. So what we need to do is we need to change the units from millimeter to meter, and then we need to enter 1000 watts per meter square. Then once I have applied the required heat flux condition, then I need to apply the convective boundary condition, for which I am going to right click, say insert, go to the convection, and I am going to select all these faces. So once I select all these faces, then I will be able to apply the convection condition. So I am going to select all these faces. So once I have selected all of these particular faces, I am going to press apply, and once I got to apply, I think I need more faces to select. We have got all the faces. Now the film coefficient that was given in the problem is 30 watts per meter square degrees centigrade. So I need to enter 30 here, and the ambient temperature is 28 degrees centigrade, and the ambient temperature is 28 degrees centigrade. And once I have given all these particular conditions, I am going to right click and say solve. Once solution is done, you can just right click on this particular solution branch, say insert, go to thermal, go to temperature, and you can just right click and say evaluate these temperatures, and this is the distribution of the temperature inside this particular heat sink. You can also see the animation of how the heat is being flowing into this particular object from the bottom side. Even you can also use the vector display if you are going to calculate the heat flux, because heat flux is a directional property. And once we have finished this thermal analysis, in the next lecture I am going to teach you how to add these results to your structural analysis and find out the thermal stresses inside this particular heat sink.